Hey guys, this is Mrs. Keith, and today we're going to do notes over finding the area and perimeter of two-dimensional shapes. You did this in middle school a little bit, but we're just going to beef it up a little bit. Okay, so the one thing that I want to make sure that I make clear is that when you're doing area, all of the dimensions that you're multiplying together, they must be perpendicular. So that's what I've handwritten across the top. You have to see that little right angle symbol for the dimensions when you're multiplying them together in order to know that you're truly finding the right area. So let's look at this parallelogram over here. I've kind of highlighted all of these just to save some time. But this particular picture, this would be our base. This would have to be our height in order to make sure that it's perpendicular to that base. So this would be the height for that base. I could not use this little part right here as a height because it's not perpendicular. I couldn't use this as a height. It's not perpendicular. Now, the base does not have to be the thing that you're sitting on. It could have been this leg over here, but then your height would have had to be coming from this way, being perpendicular, which is possible. But the important part is that your base and your height are perpendicular. And when you do the area, the formula for that is area equals base times height. A rectangle is nice because if you'll recall on its properties, you've got 4 right angles. So you automatically have dimensions that are perpendicular. So if this is the base, this would be my height. And again, the formula for this would be area equals base times height. A square is a rectangle. So you have 4 right angles. And so again, you've got your base and your height. And you can still do area equals base times height. Another thing special though about a square is that all the sides are the same. And so you could also say it's area equals side squared because your base and your height, when you multiply them together, it'll be the same dimension, so you're squaring it. So that's another option. Now, a square is also when it tells me my battery's low, I didn't realize that it makes it pause. So I don't know where I stopped there. But like I was saying, a square is also a rhombus. And so when I talk about the rhombus here in a second, I'll come back and add another formula for the square. All right, a triangle, its formula is area equals 1/2 base times height. Again, the base and the height have to be perpendicular. All dimensions must be perpendicular whenever you're finding the area. So on this obtuse triangle, the one on the left, you've got a base right here. This could not be the height because it's not perpendicular. This could not be the height because it's not perpendicular. So we have to draw the height on the outside of the triangle in order to make sure that's perpendicular. So this would be my height right here. On a right triangle, it's nice because you've got a base and a height automatically that are perpendicular to each other. On an isosceles triangle, what's special about an isosceles triangle is that you've got 2 legs that are congruent. So if this is my base, your height has to be drawn on the inside like this, perpendicular to that base. Another thing that's kind of special about about an isosceles triangle is that not only do you have 2 legs that are congruent, when you draw that height, it's going to break this base up into 2 congruent parts also. So just something to know about, and that's only on an isosceles or an equilateral triangle where that happens. Okay, equilateral triangle means all your sides are equal. So if this is my base down here, again, I'm going to have to draw that height on the inside to make sure it's perpendicular. And so my formula is still area equals 1/2 base times height. An equilateral triangle is a little more special too, though. I'm going to add something on here if I can erase this. Let me kind of erase all that. See. Okay, another special thing about an equilateral triangle. Let's say your sides are all x. So there's your height. This is x down here, but when you drew that height, we broke it up into 2 equal parts. So this is 1/2 x here and 1/2 x here. So the way it's going to work out, and you could do the Pythagorean theorem. If you focus on the fact that you have a right triangle right here, you could do the Pythagorean theorem to figure out the height. What I want to show you though, without having to do this, and we're going to do this later when we talk about 30, 60, 90 triangles and some other things, but this height would end up being square root of 3/2 times x. And then there's a special formula when I multiply area equals 1/2. The base of this triangle would be all of this length here, which would be x, times the height, which is square root of 3 over 2 times x. You end up with a formula that's area equals square root of 3 over 4 times x squared. So this is another option for the area of an equilateral triangle. You could either do the area equals 1/2 base times height, or if you wanted to memorize another formula, you can memorize that one. I typically just do the area equals 1/2 base times height, but if you didn't want to have to figure out the height and you have the sides, that works also. Okay, on a circle uses the radius. The radius is drawn from the center to the edge of the circle. That's your radius. And I've been telling you this whole time that everything you multiply together has to be perpendicular. Well, on a circle, and we're going to talk about this later, there's a tangent line right here where it just touches the circle in one point. And we'll talk about this much later, and we'll learn about how the radius is always drawn perpendicular to that. So that's, the part that's perpendicular that we're thinking of. Let's see if I can erase that. Oops. So when we do our formula for the area of a circle, its area equals pi times the radius squared. Trapezoid. I've got two bases. I've got the bases, if you'll recall when we talked about trapezoids earlier, are the parts of the the parts of the quadrilateral that are parallel to each other. This is parallel to this. And there's two of those bases. I'm going to name this one B1 and this one B2. And my formula is going to be area equals 1/2 the height times the two bases added together. And your height is going to have to be perpendicular to both of those bases, like that. Let's see. Yeah, so you're just going to want to make sure that you draw your height on the inside and show that it's perpendicular there. This leg right here would never be the height because it's not perpendicular to it. All right, on a rhombus, if you'll recall, the things that are perpendicular on a rhombus are the diagonals. This would be a diagonal, and this would be a diagonal, and those diagonals are perpendicular to each other. That's one of the properties of a rhombus. So this would be diagonal 1, and this would be diagonal 2. I'm going to highlight those real quick. So we've got this and this. Those are the perpendicular parts for a diagonal. So your formula is area equals 1/2 diagonal 1 times diagonal 2. Notice there is no plus sign right there. That's all multiplication. And again, the things that you multiply together have to be perpendicular. So we talked about earlier about how a square is also a rhombus. So if you, remember on a square, it also has perpendicular diagonals. So it could also use that formula 1/2 diagonal 1 times diagonal 2 if you wanted to. All right, one more formula is the area of a regular polygon. Okay, remember when we talked about regular, that meant all of your sides and angles were equal to each other. What this formula is, it's going to be area equals 1/2 the apothem times the perimeter, which that apothem word is pretty new. Apothem. And the definition of an apothem is that it's drawn from the center of the polygon perpendicular to one of the sides, and can be to any of the sides. And because it can be to any of the sides, you should think about how it, you need all of those sides technically, where they're perpendicular to each other. So that's why we use the perimeter, because you're getting every one of those apothems, or you're taking care of all of them when you do the perimeter. So the apothem is A, perimeter of that figure is P, capital P. Another thing I would like to show you inside of here, let's see if I can erase all that. So technically, you have your center right here. This is called the radius of that polygon. It's drawn to the vertices. And that's a isosceles triangle right there. Those radii are congruent to each other. And so this is the height of that triangle right there. And then you've got how many of those. It should match how many legs that you have on the polygon. And then here's the height for each one of them, which are all apophthegms. So you could find the area of, that triangle right there by itself, and then multiply it by how many of those triangles that you have, if you'd rather do it that way. Either way is fine, but this formula works if they give you the apothem. That apothem is just the height of that little triangle right there. Always drawn from the center of the polygon perpendicular to one of the sides. All right, I have an answer key for this set of notes on Canvas. I know it's kind of hard to read with this Apple pen that I'm writing with, but you might go back and look at the notes that I have in Canvas. They're a little more clear. And then I'm going to do a separate video for the in-class practice. All right, thanks.